Welcome to our deep dive into the world of wire ropes. These deceptively simple tools are essential to so many industries. You probably see dozens of them every day without even noticing. Today we'll explore the essential components and classifications of this crucial mechanical device that's been holding up bridges and hauling in ships for centuries. We're going to cover the basic anatomy of a wire rope, from the individual wires to the different types of lays and cores. Then we'll get into the materials and coatings so you can tell you're galvanized from your bright steel. Once you understand the basic construction of wire rope, you'll be able to choose the right rope for the job and use it safely and effectively. Let's get started. We're going to start with the most basic element of a wire rope, the wire itself. These are usually made of high-strength steel, although other metals can be used depending on the application. The diameter of the individual wires will have a huge impact on the rope's flexibility and strength. Thinner wires mean more flexibility, while thicker wires equal more strength. Of course, there's always a trade-off. You can't just use one wire, though. That wouldn't be much of a rope, would it? That's why they're laid together in a helical pattern to form strands. And guess what? The direction those wires are laid in makes a difference too. More on that later. The important thing to remember about the wires is that their properties directly affect the overall performance of the rope. It's all connected. So next time you see a wire rope, take a closer look and appreciate the complexity of these simple-looking components. Moving up from the individual wires, we come to the strands. These are groups of wires twisted together in a specific helical pattern. Think of them as the building blocks of the rope. The number of wires in a strand, the direction they're twisted, and the way they're laid around the core all contribute to the rope's overall strength, flexibility, and resistance to abrasion. There are tons of different strand constructions, each with its own unique properties and advantages. For example, a 6x7 strand, which is super common, has 6 wires twisted around a single central wire. But it can get much more complex than that. You can have strands with dozens of wires, multiple layers, and different twist directions. It all depends on the specific application and the desired properties of the rope. It's like braiding hair, but instead of making your sister's hair look pretty, you're engineering a mechanical marvel. At the center of it all lies the core, the unsung hero of the wire rope world. It provides the foundation upon which the strands are laid, dictating the rope's overall shape and flexibility. The two most common types of cores are fiber core and steel core. Fiber cores, usually made from natural or synthetic fibers, offer flexibility and shock absorption. Steel cores, on the other hand, bring extra strength and crush resistance to the table. They're less stretchy under load, which is super important in applications like cranes and elevators where precise control is key. Choosing the right core depends on the intended use of the rope. A fiber core might be perfect for a towing line where some give is beneficial, while a steel core is essential for heavy lifting applications where stability is paramount. It's like the difference between a flexible yoga mat and a sturdy weightlifting belt. Okay, we've talked about wires, strands and cores, but there's another crucial element to wire rope construction that often gets overlooked: lubrication. It may not be the most glamorous topic, but trust me, it's important. Just like any machine with moving parts, wire ropes need lubrication to reduce friction between the individual wires and strands. This helps prevent wear and tear, extending the lifespan of the rope. Lubrication also helps protect the rope from corrosion, especially in harsh environments like offshore drilling platforms or chemical plants. The type of lubricant used will depend on the specific application and operating conditions. Some ropes come pre-lubricated during manufacturing, while others require regular lubrication in the field. Neglecting lubrication is like running your car without oil. It might work for a little while, but eventually it's going to lead to some serious problems and a much shorter lifespan. Now, let's talk about the different materials used to make wire ropes. The vast majority of wire ropes are made from steel, but not all steel is created equal. Carbon steel is the most common material for wire rope. It's strong, durable, and relatively inexpensive. However, it's more susceptible to rust, especially in humid environments. For applications requiring higher strength and better corrosion resistance, you'll want to look at alloy steels. These steels contain additional elements like chromium, nickel, and molybdenum, which enhance their properties. Stainless steel is the gold standard for corrosion resistance. It's often used in marine environments, chemical plants, and other applications where exposure to moisture, salts, or acids is a concern. Choosing the right material is crucial for ensuring the longevity and performance of the wire rope. It's all about finding the right balance of strength, durability, and cost-effectiveness for the specific application. In addition to the material itself, wire ropes can be further protected from the elements with various coatings. These coatings provide an extra layer of defense against corrosion, abrasion, and other environmental factors. Galvanized steel is a popular choice for its excellent corrosion resistance. The zinc coating acts as a sacrificial barrier, protecting the underlying steel from rust. Bright or uncoated steel is exactly what it sounds like: steel without any protective coating. It offers maximum strength, but it's also the most susceptible to rust. You wouldn't want to use this in a wet environment. There are also specialized coatings available for specific applications, such as those resistant to extreme temperatures, chemicals, or UV radiation. Choosing the right coating is like choosing the right armor for your rope, protecting it from the elements and extending its lifespan. We've talked about the importance of lubrication, but let's dive a little deeper into the different types of lubricants used in wire ropes. The most common type is petroleum-based oil or grease. It's readily available, provides good lubrication, and offers some protection against corrosion. For higher temperature applications, synthetic lubricants are a better choice. They can withstand extreme heat without breaking down, ensuring smooth operation and preventing premature wear. Dry lubricants, such as graphite or molybdenum disulfide, are ideal for environments where liquid lubricants aren't practical. They provide a dry, slippery film that reduces friction and wear. Choosing the right lubricant is crucial for maximizing the lifespan of your wire rope. It's about matching the lubricant to the specific operating conditions and environment. Now that we've covered the basic components and materials, let's move on to the different ways wire ropes are classified. One important distinction is by core type, which we touched upon earlier. Fiber core ropes, often referred to as FC ropes, are known for their flexibility and shock absorption. The fiber core allows the rope to bend easily, making it ideal for applications like cranes, hoists, and towing. Steel core ropes, or SC ropes, offer superior strength and crush resistance. The steel core provides a rigid backbone for the rope, making it suitable for heavy lifting, suspension bridges, and other applications where minimal stretch is essential. Choosing between an FC and SC rope depends on the specific application and the desired balance of flexibility, strength, and stretch characteristics. It's all about finding the right tool for the job. Another important classification of wire rope is by lay, which refers to the direction the strands are twisted around the core. This might seem like a minor detail, but it has a significant impact on the rope's handling characteristics and performance. Regular lay ropes have strands twisted in the opposite direction of the wires within the strands. This creates a rope that's relatively stable and resistant to kinking and unwinding. It's often used for general-purpose applications. Lay ropes have strands and wires twisted in the same direction. This results in a more flexible rope that's resistant to abrasion and fatigue. It's often used for applications involving repeated bending, like mining and dredging. Alternate lay ropes combine features of both regular lay and lay ropes. They offer a good balance of stability, flexibility, and abrasion resistance. Choosing the right lay depends on factors like the application's demands for flexibility, rotation resistance, and abrasion resistance. Finally, wire ropes can also be classified by their construction, which refers to the number of layers of strands around the core. Single-layer ropes, as the name suggests, have a single layer of strands twisted around the core. These ropes are typically used for lighter-duty applications where flexibility is important. They're often found in small cranes, elevators, and control cables. Multi-layer ropes have multiple layers of strands wrapped around the core, providing increased strength and resistance to crushing and abrasion. They're commonly used in heavy-duty applications like large cranes, oil rigs, and suspension bridges. The number of layers in a multi-layer rope can vary depending on the desired strength and diameter. Some ropes can have up to 6 or more layers of strands. Choosing the right construction depends on the specific application and the required strength, flexibility, and resistance to crushing and abrasion. Thank you for joining us on this journey through the fascinating world of wire ropes. We've covered a lot of ground today, from the individual wires to the different types of lays, cores, and coatings. Hopefully, you now have a better understanding of the complexity and versatility of these essential mechanical devices. Remember, choosing the right wire rope for your application is crucial for ensuring safety, performance, and longevity. Stay tuned for more informative content, and until then, happy lifting. Follow my channel for more content.